Hello friends, welcome to my house. We are going over the test. This is the second test I gave you on derivatives, just going to be the second page. So, second page opens up. We want to find the limit as h goes to 0 of tangent pi over 4 plus h minus 1 over h. Now this initially looks very scary because you haven't done limits in a while, and this looks like a nasty limit, but there's a couple hints. This h goes to 0 and h in the denominator, plus, inside the parentheses here, this plus h, suggests that this might be a definition of the derivative problem. Now, if you recall, and you should recall, because you need to recall, the definition of the derivative of a function is going to be the limit as h goes to 0 of f of x plus h minus f of x over h. Now, most of this is pretty intact if f of x equals tangent. We've got this tangent of something plus h. We've got over h. The only thing is this 1. In order for that to fit, we have to check, is tangent of pi over 4 equal to 1? And yeah, it is. Hooray! So that means this is of the form limit as h goes to 0 of tangent pi over 4 plus h minus tangent of pi over 4 all over h. Now, what does that mean? Since this is the definition of the derivative, that means this problem is telling us take the derivative of tangent, which happens to be secant squared, and plug in this number, pi over 4. So we're asking, what is the secant squared of pi over 4? Well, the secant of pi over 4 is the square root of 2. And the square root of 2 squared is just equal to 2. So that is how you do one of those. Next up, we have another one, some words here. If f prime of x, so notice that they're giving us the derivative, not the actual function, equals sine of x to the third, at what value of x does f first achieve a maximum, right? Okay, so we don't really know, and we could answer this if I had just given you f, but I give you f prime, so it's a little bit different. If it's a maximum, the derivative should be equal to 0, and it should go from positive to negative, right? So here's the maximum, here f prime is positive, here f prime is negative. And so we think about ourselves, our outside wrapping function, like the outermost layer, is sine. And we should have a pretty clear idea of what sine does. So just as a matter of course, sine of 0 is 0, then sine goes up, comes down, comes up. That's about as far as we need. So when is the outermost function equal to 0? Well, here at 0, and we'll extend a little bit negative, and here at pi. Make that a better pi. Now, here, of course, it's positive, and here it's negative. So the question, well, we know some zeros. Here it is again at 2 pi. Which one do we choose? And this one is out because here the derivative would have to go from negative to positive. We want the derivative going from positive to negative, so this is the one we want, right? We want to take the sine of pi, which means that x to the third has to equal pi. That'll be if it is first time, which means that, of course, x has to be equal to the cube root of pi. If you really like it, and I appreciate you doing so, you could write this as pi to the 1/3 power. Both of these are perfectly acceptable answers. I would love to see either in your work. The first achieved maximum, don't let that throw you. That's just kind of a technical thing. Since sine is periodic, this of course has an infinite number of maxima. So no big deal there. We have f of x equals the square root of x squared minus 4, and g of x equals 3x plus 2. Find d dx, so the derivative of f of g of x when x is 3. Okay, now, you can plug in and simplify, and certainly that's a way to do it. But let's just establish what this would be from the chain rule. By the chain rule, the derivative of this is going to be f prime of g of x times g prime of x. Okay, well, we can start by getting some derivatives going here and some other things. So if we're looking at x equals 3, we're going to need to know g of 3. So actually, what we want isn't this. It's f prime of g of 3 times g prime of 3. Well, some of these we can find right off the bat. So g of 3 is, of course, 3 times 3 minus 2, which is 7. We need g prime of 3, so g prime of x is just 3. So g prime of 3 is, of course, 3. So that's most of the parts. Now let's look at f prime. We're going to rewrite this as x squared minus 4 to the 1/2 power. So that means f prime, we're going to use the product rule, and power rule, and we're going to use the chain rule. Is equal to 1/2 x squared minus 4 to the negative 1/2 times derivative of that is 2x. The 2 and the 1/2 cancel. So we get x times x squared minus 4 to the negative 1/2. Now, we want to take f prime of g of 3. Well, g of 3 is 7, so we'll just plug in 7. This part becomes 7 times 7 squared minus 4 to the negative 1/2. Then we multiply by g of 3, which is, well, 3. This becomes 49 minus 4 is 45. So different ways of writing this. I've seen, you could say just have 21 times 45 to the negative 1/2. That's perfectly fine. Various avenues of simplification you should be aware of. This is also known as 21 over the square root of 45. Since 45 is 9 times 5, this is 21 over, since the square root of 9 is 3 times the square root of 5. So 7 over the square root of 5. Now you may remember that most math courses want you to rationalize the denominator, and we have not yet rationalized the denominator. So the final step to get the most simplified version is multiplied by square root of 5 over square root of 5. We get, kind of ran out of room here, so right over here, 7 square root of 5 over 5. This is the final simplified answer. You don't need it, but you should be able to recognize it. Oops. 4. Y equals 3 divided by 2x minus 4 for what values of x is y concave down? Now, again, you might have seen this problem before. If you took the retake, you've seen this problem twice now. This one does not require calculus to do if you know a little bit something about rational functions. So we know that this rational function has a positive numerator, and it has a 0 in the denominator when x is 2. Which means it looks like this. For which values of x is y concave down? Well, this whole region. So we know that the answer should just be x is less than 2. But let's say you forgot that and want to do it by calculus, which is just fine. We're going to take this, and a lot of people really want to use the quotient rule for this. And I'm not saying that's wrong. You can absolutely use the quotient rule for this, but it's a lot of work. Maybe don't do it. Maybe rewrite y as equal to 3 over, well, not 3 over anything, 3 times 2x minus 4 to the negative first power. Then take the derivative using the power rule. So that means dy dx has to be equal to 3 times negative 1 times 2x minus 4 to the negative second, and then the derivative of the inside is times 2, which we can rewrite as negative 6 to the 2x minus 4 to the negative second. Then we do it again, because concavity, we need to know about the second derivative for that. So we'll take the derivative again. The second derivative of y in terms of x is going to equal to negative 6 times negative 2 times 2x minus 4 to the negative third power times another 2. Again from the chain rule. So all of that is to say that equals 24 2x minus 4 to the negative third, right? And now we did that, and now what do we want out of it? We want to know when this, if we're looking for concave down, is less than 0. Well, if we're worried about when that's less than 0, then this doesn't matter at all. And in fact, since that's equal to 1 over 2x minus 4 squared, that'll be negative when, if it's to the negative third power, well then it only depends on when that's less than 0, so that also doesn't matter. We're interested in when 2x minus 4 is less than 0, which means 2x is less than 4, which means that x is less than 2. Again, same answer we got over here, with just an examination and knowing something about rational functions, but in this one you don't have to know anything about rational functions. You just need to apply some calculus, and it still gets you there, which is nice. All right, here we go. This one's got some more words. If f of x is continuous and invertible on the closed interval from 3 to 10, where f of 3 is 25 and f of 10 is 3, what theorem guarantees that the inverse function of 14 is between 3 and 10? Now, since it is what theorem, there really is, you just have to know which one it is. Key points are continuous. You really only know 2 theorems, the mean value theorem and the intermediate value theorem. And if you can remember just one thing about either, that's enough to tell you which one this is, right? So if you remember that the mean value theorem needs continuous and differentiable, right? Which I didn't tell you it's differentiable. I told you it's continuous and invertible, right? That means the mean value theorem doesn't apply, and it has to be the intermediate value theorem, which is kind of a sad way of looking at it, but that's okay. Why is it the intermediate value theorem? Well, it's the intermediate value theorem because this 14 is intermediate. It's between 3 and 25, right? Which means there has to be an x somewhere between 3 and 10 so that f of x equals 14. That's really what the intermediate value theorem is saying. This is just saying this in a little bit backwards because we're talking about going through it as an inverse, right? We're talking about it slightly backwards, but it works the same. It is the intermediate value theorem. Okay. Finally, a straightforward question. Find the derivative of the 5th root of x to the 3rd minus 3. All right? Find the derivative. So we have this. We're going to rewrite it as x to the third minus 3 to the 1/5 power. So if you see this number nestled here, that forms, we can turn that into a rational power where that is the denominator. And then we apply the power rule. So the power rule says we take our power, make it a coefficient. We have 1/5. We keep this the same for now, x to the third minus 3. Then we have to subtract 1 from the power. 1/5 minus 1 is negative 4/5. Then you have to multiply, the chain rule applies. So you multiply by the derivative of this inside. Derivative of 3 is 0. Derivative of x to the third is 3x squared. And there you have it. You can stop there if you want. If you want to make it look a little bit nicer, you could say that this is the same as 3x squared over 5 x to the third minus 3 to the 4/5. This is another way to write it. If you need it in root notation, then you would write it 3x squared over 5 fifth root of parentheses x to the third minus 3 parentheses to the 4th power. All of these are equivalent ways. I accept all of them. They're all great. Whatever one makes you feel happiest. Now, another straightforward, find the derivative of the tan inverse of 3x. This requires you remembering what the derivative of tangent inverse is, which I think I gave to you, so you could just look that up. Derivative of tan inverse is 1 over 1 plus, and that's whatever is in here squared. Right? Except the chain rule applies, so we have to multiply by the derivative of the inside. The derivative of 3x is 3, so our final answer is some variation on 3 over 1 plus 3x squared. I would also accept 3 over 1 plus 9x squared for those who want to distribute that. And then that's fine. I like it either way. Finally, I think, we have this problem. F of x is equal to 2x minus 1 to the 5th power times x plus 1. Find an equation for a line tangent to the curve when x equals 1. All right, so if you need an equation for a line, you need two things. You need a point. At this point, we have the x, and we need a y. So we have 1, and we're not sure what that is. So we'll go through here. F of 1 is equal to 2 times 1 minus 1 to the 5th power times 1 plus 1. Well, that's equal to 1 to the 5th times 2, which is just 2. There's our point. Excellent. Now, we need a slope, which is typically, for this case, since we're looking for tangent, always check to make sure you're getting the slope for the right thing. The slope is going to be just f prime at 1. So we take the derivative. This is a good product rule derivative. This is a fine setup for the product rule. So as we've been doing it, it's going to be the first 2x minus 1 to the 5th times the derivative of the second, which is just 1, plus the second, x plus 1, times the derivative of the first, which is, using the power rule and the chain rule, 5 times 2x minus 1 to the 4th times 2. Keep in mind, remember that 2 on the inside. That's from the chain rule. So we could make this nice and simpler, but we're not going to because we know it. We want it at a particular point. So we're just going to plug that in. We want 2 times 1 minus 1 to the 5th times 1 plus 1 plus 1 times 5 times 2 times 1 minus 1 to the 4th times 2. All right? This is 1. 1 to the 5th is 1 times 1 is 1 plus we have 2 times 5 times 1 to the 4th times another 2, which becomes 1 plus 20, 21. So that's our slope. We have a point, we have a slope, we'll write the equation, starting out in point slope, and if we need to edit it for multiple choice concerns later, we can do that. So the point slope version is y equals the y-coordinate 2 plus the slope 21 times x minus 1. And there you have it. All right, that was it. Thanks for stopping by. I'll see you on the next video.